Hey folks, if you're just joining us, we're doing the Advent of Code series where there's a new coding puzzle every single day until the day of Christmas. And today it's day 3, binary diagnostic. So let's, uh, as usual, let's go to the folder and create a new day 3 from our template. And I think we should have everything, the part 1, part 2 function. Let's just change the test name. So it's called day 3 binary diagnostic. Awesome. So let's just test run this npmt 2021 day 3 and it should pass. All right, let's go on. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. This diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. All right, so let's first copy our sample and actual input. So this is my sample input. Let's go to and copy our input. We're done. Now, if we try to run our test, it should fail. And let's continue. I think we were here. You need to use the binary numbers in the diagnostic report to generate two new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. So at the end, we're just multiplying these two variables that we got. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, so we have like a bunch of binary numbers. Considering only the first bit of each number, that's all right. There are 5 bits and 7 1 bits. So there are 5 zeros and 7 ones. Since the most common bit is 1, the first bit of the gamma rate is 1. All right, so basically the gamma rate is calculated by getting the most frequented value in this, this column, basically. If we take a look at our input as a sort of a table, where these are the rows and these are the columns, as in these individual items are rows and these are columns, we would, in the first column, we can see that there are 5 zeros indeed and 7 ones. So basically 7 would be the most common bit, hence the first bit of our gamma rate. The most common second bit of the numbers in the diagnostic report is 0. And so the second bit of the gamma rate is 0. So we have 0, 1, 0. Okay, there's clearly more number of zeros. So that is the next bit. The most common value of the third, fourth, and fifth are 1, 1, 0 respectively. And so the final 3 bits are 1, 1, 0. So the gamma rate is basically 1, 0, 1, 1, 0. And that is 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, it calculates the least common bit from each position that it's used. So the epsilon rate is 0, 1, 0, 0, 1, or 9 in decimal. And actually, there's something interesting about this. The gamma rate, which is the binary number here, it's probably going to be the opposite value in binary. So, if the most significant, most common bit for the gamma rate is 1, then the least is obviously going to be 0. There's no other way to it. So if we were to invert this binary number, we would get the epsilon rate immediately. All we need to do is multiply the value and get it right there. All right, so this is our task. Let's take a look at what we can do right here. Let's return input.length initially, const input lines. I guess we can call. I guess we can just call it binary. Yeah, bytes. This entire thing is okay. Yeah, I guess I can just call it input lines. Input lines is input.split by /n. Now, for each individual line, what are we going to do? We basically need to, like I said, we're going to take a look at this in a table. So the best data structure to hold this would be a matrix. A matrix in JavaScript or basically any other programming language It's represented by multiple arrays or two-dimensional arrays, or n-dimensional arrays if it's like a multiple matrix. So in this case, it's the matrix is of size 5 rows, I believe. No, I mean, okay, n rows and 5 columns. So it's sort of going to look like this, where we have the first array, and then inside the first array, we have another array which is going to have these values. So 0, 0, 1, 0, 0. And for the next one, I mean, we have 4 ones and 0. So it's going to sort of look like this 1, 1, 1, 0, 1, 0. So for 1s and 0, it's sort of going to look like this. So we can access any particular item or cell in the matrix by, I mean, let's assume this is called ARR. We would access it by calling ARR of 0. I mean, if we want to access this one, perhaps we would call it ARR of 1, and the first element right here. So ARR of 1 of 1. If we would need to access this one, it would be 0, 1 to the third index element. So it would be A of 1 of 3, and it would get this cell. So I think that's the approach that, again, not the best approach. Not really sure what the best approach is, but this seems like a really good approach for this particular use case using matrices. So in the helpers function, I have like a bunch of functions that kind of help for matrices. We can make use of that. I will be explaining what these actually do, but not really important right now. The main thing is I have exported a type right here, and this is just important for TypeScript, explaining what type of element this is. So it's an array of arrays, which provides this. So that's what we need. Let's go back to our input and create. I guess we can create our matrix given the values we have. So let's go through input lines. Input lines dot map. I think it's good if you map it. Let's create a matrix as well, and of type matrix of I mean, do we really need numbers? I mean, I guess we can call it number. All right, so we're going to get in each individual line, and this line is basically a string of I mean, where's our input? It sort of looks like this. We need to split this. So let's call it bits, right? And what we might need to do here is line.split with no separator, because we would want each individual item, and also map each item as I mean, I would need to parse int. So I can't do number. I don't think I can do number, but let's just check it out. I'm gonna console log bits, and yeah, let's see. All right, so I mean, I guess I can do console log bits. I mean, I guess I can do map number. It returned the number for me, so that's all right. I was worried whether returning 0 would say something else, print something else, but yeah, it's all good. So one thing that I forgot is we're going to comment out all other tests and keep just our sample, so it's easy to test. So let's do this, and yeah, we should get all the inputs. Now let's go through each one of those bits and see what we need to do. We need to basically update them into our matrix, right? So I mean, actually, what we could do right now is just the value that we're returning, return bits, right? And then we would just be able to the map function returns like an array of these bit arrays. So all we need to do is return this into our matrix, and it would fit in perfectly. Let's remove this line, and yeah, that's it. It's a number of two-dimensional arrays. I guess I can actually return this directly instead of using that intermediate variable. Sort of saves a few lines, and we're done with this. So now, taking a look at the question again, what we need is basically the value of just the column. So I need just the column of just the first column, second, third, and so on. So if we need to get a certain number of columns, I guess we can just start off with counting how many columns there are. So for that, I guess we can go with a regular for loop, the one we know and love. I'm going to start from 0 and say matrix of 0 dot length. So it doesn't matter what number we put in here because we're just basically picking any random row. We're just picking 0 because we know it'll exist. So matrix of 0 dot length, less than length, and then I plus plus. This should loop through the number of columns. Loop through this array, number of columns. All right, let's actually find out how we can get our individual columns instead of getting like the entire cell. Because if you remember, I just said if we were to get an entire row, we can do something like this, but we can't get individual columns just as easily. We would need to, basically, we can only get cells by doing this. So if I need to get a column, I would do something sort of like this. So matrix of map, and I would get individual rows, right? Rows is, let's confirm that it's a number array, and I would need to get rows of I. So this would return an array wherever, so in the first iteration of the loop, let's run through this, we have I of 0. So it would get me only the first item in all of the rows. So it would get 0 in this row, 1 in this row, 1 in this row, and so on. So that way the final result of this map would be an array of all the items in the column for each for loop. So this is basically the answer to my column. Now all I need to do is find out what is the most significant bit in this column and least significant bit. So yeah, let's sort of do that. I can, all right, we have column. We would need to, I believe we could sort, no, sorting wouldn't really be a good option here. Let's think about it. If we have, I mean, the brute force way of going about it is just, going through a for loop and then counting the number of zeros we have, counting the number of ones we have. And then if we have more number of ones, we just do what we need to do. But I'm just trying to think if there's a better way to do it. I guess we can start off with a count. I do remember that in our helper function, helpers, we have a count by. So what count by does is, again, it uses reduce, because if you remember the first video, I spoke about why we use reduce wherever we would need to pass in an array and then return just one value. In this case, we would need to return one single object with some information. So what count by does is basically it returns a record, or record is just a fancy name for object. It returns an object with the key as the value, I guess, of the arrays or the items in the array. In our case, it's 0 or 1. And the value to the object would be the number of times it repeats. So it would basically return an object of, 0 is to 5 and 1 is to 7. So that way we would easily be able to find out how many times, which number repeated. So let's sort of do that. I'm going to call count by column, which would return a map, right? So I'm going to call this maybe bitmap. Yeah, names are, not my forte, but yeah, let's call that bitmap. And what we need to do here is, okay, I guess bit count. Yeah, that's better. So what we need to do here is basically, it's a record of, I believe we can just call this number. So, I mean, it's of type number. I can just pass in number right here. Does it not work that way? All right. I would need to typecast it as this. So this is just TypeScript stuff. What I'm doing is forcing, I mean, it says it returns a type of any, but I'm forcing it to be a number because I know the value is a number. So now that we have, bit count as a record of number and number, all we need to do is loop through bit count. So what I can do here is for const bit of, I mean, I guess I can do a sort of key value for this and call in instead of this. So for key value in bit count, and this is again ES6 syntax, if given an object or JavaScript object or a map or something like that, we would be able to const for in instead of for off, and it would get us the key and value, and we can loop through the object just as easily as an array. So in this, I'm going to check if the key is indeed a 0. So if it is a 0, the value would, I mean, I'm not really going to check if the value is like set. I'm actually going to check if the value, that's a good question. I don't really need the for loop. Yeah, that's a mistake on my part. I wouldn't really need the for loop because, it just has 2 items. We know that. We know that it has 0 and 1. All I need to do is check whether bit count of 0 this returns the value, right? This returns the count of numbers is greater than bit count of 1. So this would mean that if zeros are greater than 1, I would need to return 0 as the significant bit for my gamma rate. So let's actually create those variables for gamma rate. I guess I can do it right here. This would be a good place. Let gamma rate be an empty string for now. And yeah, I know there's supposed to be numbers, but I'm gonna keep them as strings for now because we can easily concatenate them. Considering that they're still binary, they're not really numbers. So we got our gamma rate, and we also need one more variable. I'm trying to find out what that is. Epsilon rate. All right, that's the thing. Epsilon rate. Awesome. So we have 2 variables which we need to modify. So if bit count of 0, if the number of zeros are greater than the number of ones, then our gamma rate would be plus equals 0. And it's a string, so let me just update that as a string. And if in this case, if it's greater than 0, then the epsilon rate would be 1. On the other hand, if the alternative is, it is the alternative where 1 is greater than 0 and the number of ones is greater than 0, I would just reverse this. So gamma rate would then become 1 and epsilon rate would then become 0. So I think this should work. We have all these values. Finally, we need to convert our binary number into a decimal. And JavaScript does make that easy for us. All I need to do is gamma rate. I believe I can do equals and parse int. That's the function we're looking for. Parse int this string, which is gamma rate, and the radix. So radix. So basically, if I would pass 2, which is the radix for decimal numbers, it would convert whatever string that I have here or number that I have here into decimal. So I would just need to do this twice, one for gamma rate, one for epsilon rate, and update the values of the original variables. Once I have that, all I need to do is multiply the gamma rate and epsilon rate. So let's do just that, gamma rate into epsilon rate. So looks like I do have a number of errors. Type number is not assignable to type string. Okay, I kind of expected this. So basically in TypeScript, we are setting this it infers that it's type string. We can possibly set it as number as well. It can either be a string or a number. So we're doing that right here so that this error goes away. And now it's possible. It is of type number at this rate. Now let's run the test and see if it actually works. Okay, we didn't update our test so we didn't actually find out what the answer is. The answer is supposed to be 198 when we multiply the sample 22 into 9. So let's actually update that into our test. I could see that is what we got. So the test pass. Now let me run this for the actual input as well and get our answer. Hopefully it should be all right. And the answer is 200336. 3336. All right. Is it right? Yes, it is. So we can safely update that in our test and make sure that that passes. Now let's continue to part 2. All right. So like a lot more in store right now. Let's take a look. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. So basically a whole lot of new variables, I guess. Both the oxygen generator rating and CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Okay. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. So we did do that. We sort of got the first bit of all the numbers. That's basically the entire column. Then keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. If you have only one number left, stop. This is the rating value for which you are searching. Now, to be honest with you, I'm actually kind of confused in what the process is. But I do believe that once I take a look at the sample or take a look at an example, that would sort of help. So let's just keep reading on. The bit criteria depends on which type of rating value you want to find. To find oxygen rating, generator rating, determine the most common value, 0 or 1 in the current bit position. And keep only numbers with that bit in that position. All right. If 0 and 1 are equally common, keep values with a 1 in the position being considered. To find CO2 scrubber rating, determine the least common, and if they are equally common, keep values with a 0 in the position being considered. All right, let's take a look at the example because honestly, I didn't understand a thing. For example, to determine the oxygen generator rating value, using the same diagnostic report from above, start with all 12 numbers and consider only the first bit of each number. So similar to our process, we would need to extract the column. Right? I believe we did that here. We extracted the first bit array. And then, and this would, okay, let's start here. There are more 1 bits than 0 bits. So there's more number of ones than zeros, 7 versus 5. So keep only the 7 numbers with a 1 in the first position. All right, so basically in our matrix, we're basically removing items from our matrix. We're removing rows from our matrix. Then consider the second bit of the remaining 7 numbers. There are more 0 bits than 1 bits, so keep only the 4 numbers with a 0. And you are left with just these 4 numbers. This is because the second bit has more number of zeros. All right. I think I have like a slight idea on what we should do. So let's take a look at the sample input. We have the sample right here. In the first array, or in the first iteration, to get the oxygen generator value, we are going to check this section right here, this column, and we see that there are 1, 2, 3, 4, 5, 6, 7 number of ones and 5 zeros. So that basically means in the first bit, 1 is the most common bit. I can now safely remove all the other values that start with a 0, right? So I'm left with 7. Now in the next iteration, I'm going to take a look at the second column and check what is the most significant bit. And I guess most common bit instead. So here you have 3 ones and then 4 zeros. So 0 is the most common one. So I can remove all the items which have 1 as the second bit. Now clearly there is 3 ones, so we're going to keep that, remove the one with the 0, and again 2 ones, you can remove the one with the 0 in the 4th bit, and finally we have 1 and 0, and if they are equal, and that was the final question right here, if 0 and 1 are equally common, keep the values with a 1 in the position being considered. So we should keep the 1, remove the 0, 1 0 1 1 is the answer for oxygen generator rating. So 1 0 1 1 in decimal is 23. So that's sort of what's happening here, but I mean, it's easier said than done, right? Converting this into code is a task. So I believe what we could do is sort of the best way to do this, because the logic is sort of understandable. We could try to tackle the solution with recursion. that's just my thought. Let's continue reading about the CO2 scrubber rating. Start again with all 12 numbers. Consider only the first bit. There are fewer 0 bits than 7 bits, so we keep only 5 numbers with a 0 in the first position. So basically, it's similar to the oxygen generator rating, but instead of the numbers that we don't have, we're removing the numbers that we did remove in the first step. So that's what we're doing. All right, we can make use of the same function to do this as well. Okay. So how do we go about this? Let's activate our test for part 2, the sample. So the value that we're expecting should be 230. Let's just add that. And now for part 2, going to, let's say, do the same things as this. So I would need the matrix, I would need the input lines. So I'm just going to copy that over. And at the end of the day, we need to have an O2 rating and a CO2 rating. So let me create the variables for that as well. So O2 rating is set to 0, and let CO2 rating set to 0. And at the end, we would need to multiply these two values. So O2 into CO2. Now, what kind of magic would we need to do in the middle right here? I believe it would help to reduce. All right, let's start writing our function, our recursion function. So if I'm a bit dodgy with my laws of recursion, but I think we would need to write the exit condition first, exit criteria. Sorry. So let's call this reduce by most common bit. All right. So I'm not really sure what the parameters are, but we can go about them. Initially, we would need the matrix. So I'm just going to call this matrix, and it's of type matrix. What else? We would, okay, I would need a type as well. So I guess I can call this any. I mean, actually, it's a type number. So yeah, it's a number. What else would I need? I would need the column number, or basically the iteration that goes on. So because it's the first one, second one, third one, we need the iteration number. So let's call this iteration and then number. Right. Yeah, let's keep this for now. I think we can go on later with the rest. So the exit criteria is sort of going to look like this. We would want to keep calling this function. That's basically what recursion is, until this particular condition runs. So I would need to say, until the length of the matrix, this matrix that we have is 1, right? Until we have one row in the matrix. So matrix.length is, I mean, not really. Yeah, I guess I can just call it 1 is equal to 1. Then we would return. What do we need to return? We would need to return just the binary number that we have. I think we can return it as a string. That should be all right. So let's return matrix of, so it would just have one item. So matrix of 0 dot join, because it's a string, we would need, it's an array, we would need to convert it into a string. So we will return this. Now, if we would need to call this function again and again, we would need to return the function itself. So return reduce by most common bit, and then we would need to pass matrix. But if we were to pass iteration directly, this would cause an infinite loop. So that's how recursion works. If I were to do this again and again and again, we would still get, I mean, it would call us, I believe, that what we know very famously, Stack Overflow. So instead, I would need to increase the iteration number. So it would be +1. Now, what do we do with this information? That's the code that we write here. That's the core logic. So basically, I would need to get the column first. That's what we know. I'm going to do that by this. We have the code right here to get the column. That's right here. So I would need to get the column, and I is now replaced with iteration. So we would need to get the column based on the iteration number. So we could also just call this column number. But yeah, iteration. Well, actually, yeah, column sounds good. So column, Now I believe we've used column somewhere. Not really sure. Inside part 1. Not really sure why that is causing an issue, because they are two different functions. But that's weird. I guess I'll just call it iteration for now. So we got column here. I did not see that. Okay, that was my bad. Let's actually call this something else. We've got the bit array, and now, for lack of a better name, and now we would need to do the same thing. We would need to get the most common bit. So we did that in the previous example by getting bit count and getting count by, using count by. So let's do the same thing. Bit count by bit array. I guess I can call this bit array as well. This feels weird to not have the same name. All right. So we got our bit count. Now I can, I guess I can check if, no, I don't really need an if. I would need to check. Yeah, I mean, I guess I can. Yeah. If bit count of 0 is greater than bit count of 1. And if it is, I would need to return 0. But I don't really want to return. I would want to, I mean, that is my most significant bit. I would need to add that into my array. Sorry, we would need to replace that. So what I need to do is basically write another function that will return this value to me. So again, we can make use of some ES6 magic right here. So I'll call this function most sig. I mean, it's not really a function. And you'll see what I'm doing in a second. So I'm going to call this most common, not significant, most common bit. Right. So most common bit. And I would need to write a function here. And if I were to return a function, that would be a completely different thing. I don't want that. Instead, I need a function to return this value to me. So I can create a function right here like this and immediately call that here. What this syntax does, and this is called an IIFE or something like that. I would need to check that. Yeah, immediately invoked function expression. It's basically when you create a function, an unnamed anonymous function. Anonymous just means that these functions don't have names like this. It doesn't have a name like reduced by most common bit. We're creating the function with this text here, and then immediately calling it by using the parenthesis. So this is basically what makes an IIFE, immediately invoked function expression. In this concept, we also have things like hoisting and stuff like that, where you pass the variable. So let's say you have params. No, that's a question for another video. Let's actually go on. If I were to return some value right here, if I were to return 0, this would basically be the new value for most common bit right now. So I can write complex logic here instead of just doing this right here. I can copy paste an if and then do this. So now it'll run the function and return a value, and then that value would be my most common bit. So that sounds like something that we would want. All I need to do now is, if bit count, if the number of zeros is greater than the number of ones, return 0. Otherwise, return 1. And looking at this immediately, I think we can convert this into a ternary operator, because it's just really big to see this as an if condition. So I'm going to convert it by using ternary. So if this is true, return 0, otherwise return 1, and we should be done. Oh yeah, we would need to pass return finally. So we have this. This is the most common bit. Now with the most common bit, what we're going to do finally is basically get our new array. And this is an array which does not contain the values of the most significant bit. So what I'm going to say is const new matrix, or I guess I can filter matrix, because we're going to use, as it suggests, filter. So matrix.filter, because we want to get only certain values from certain rows from the matrix array. So I'm going to go through filter, and we have individual rows. I want to get rows of column. And this would basically get me the first item in every cell, right? I need to check, yeah, first cell in every column, in every row, sorry. Yeah, so I need to check if this equals the most common bit. So what this would do, filter, is that if this is true, rows of column, which is the cell, is indeed the most common bit, then it would uh, say, just return the ones that is true here, and remove the items that are false. So that would be my filtered matrix, which is similar to the function that, the example that we just went through. Now we have this matrix which filters it. We would need to pass it to the new the recursion function that we're calling again, and this would run infinitely until matrix.length equals 1. So that's where we are. So we've got that running for us. Let's actually call this function reduce by most common bit and see if it actually works. So reduce by most common bit and matrix, and I would also need to pass a column number, which initially is 0 because nothing else is. We would need to start from the first column. I can also make this a default value, column 0, and I don't need to pass it here. But yeah, it's always good to have defaults and also pass them. Now let's actually get this value. So O2 rating. Actually, let's console log this to check if we are indeed getting the value that we need. And if we were to console log right now, we should be getting the value. Where is it? 10111. That is the value we need. So let's console log and hope it works. And yeah, we are getting 10111. We successfully did recursion. I mean, not successfully. We still have one more big hurdle in front of us, which is calculating the CO2 rating. But I think it's a good step forward. Now, what we need to do is basically convert the value that we have, the binary, into a decimal value. So I would need to do parse int of this, and finally, this is our O2 rating. That's basically it. Now for CO2 rating, it's not exactly like the reverse. We can't do the same logic that we did before. This is different. We would need to, wherever we have filter, I think if we were to inverse that filter, not most common bit, but check the not most common bit, I think that should work. But let's actually check this out. If I were to, yeah, let's do that. Let's do that exactly. If I were to, let's call it, yeah, here. Let's say not equal to the most common bit. So it would always get me the least common and then filter the matrix then and there. If I were to console log this, am I console logging it? No, I'm not. Let's console log console.log. So running the test, we should get the value 10. So is the value that we're expecting 10? It is. So all we need to do is just that. So how do we pass that onto the function? Because we want to make use of the same function both times. I would want to call it here and here. So the best way to do it is sort of passing it as the params right here. So we could call it reduce by bit instead of most common bit, because we're going to make use of the same function. And we can have a parameter called most common as a boolean. By default, it would be true. And if most common, we would want the most common, all we need to do is, so what is it right here? If most common, then, do this. Otherwise, do the inverse instead. So not equal to most common bit. So I think that should work. Looks a bit messy, I know, but I think it's still understandable. And now all we need to do is, oh, I forgot. We also need to pass this into our recursion function right here. So to make sure that we pass the same thing, we copy down most common. Now we can just as easily just call true, because we want the most common bit here. and false because we don't want the most common bit here. And we should be done. If I were to call the function, the test part2 sample looks good. It's working. We are getting the value 230. Yeah, everything passed. So let's run the test for the actual input and check what the answer is. So the answer looks like it's 1877139. I'm going to pass that answer down here and it is right. Man, that was a lot more harder than I thought, but we got through it, right? We can now see that our test passed because we now updated it with the right value. And yep, our test pass. Awesome. So we're down day 3. That's awesome. Thank you so much for watching. And as always, please let me know in the comments below if there's anything that you would like for me to change, to make it easier, to make it better. And yeah, looking forward to the next one. Bye-bye.